Okay, let's get started. So for those of you who haven't had lab yet, the lab document is posted right under week 2. I did update this Monday evening, I believe. Sometime at Monday, I forget. It all blends together. So if you did look at this last week, there are some updates to that. So feel free to look at the document. You don't have to wait till lab to go through it. This week's lab is all about getting you all set up with IntelliJ, getting you cloning the examples repo, and getting you set up to start writing code for the first project. So feel free to go through that document, get things done ahead of time, or go to lab where your TAs will be able to help you out. We want to get everybody set up this week and ready to roll with the course. All right, with that. It's nice when tech works. The last lecture I had to use the desktop, the room desktop. So it's nice when tech just works. All right, so today we want to wrap up our Scala syntax lectures. This is the last lecture where we're talking about 115 concepts in Scala. We just got to brush up some syntax. We got to talk about, of course, data structures. It's on the screen. And at that point, you'll have all of the Scala background that you need, which, again, mostly syntax. You know how to do all these things. You just didn't know how to do them in Scala. We just need to learn how to do things in Scala. So today, I have just a couple slides throwing a barrage of syntax at you. Then we'll jump into IntelliJ for some examples, which I can actually do this time, instead of scrolling through GitHub like I just had to do without when my laptop wasn't agreeing with the room technology. But anyway, we'll go into IntelliJ and then see some examples in there and get you all up to speed on how to use these data structures. So, and just a quick reminder, at this point you have everything you need to be able to complete task 1 for the project. Each time a task is due, I cover the content that you need to complete that task the previous week. So last week we covered everything you need for task 1. This week we'll cover everything you need for task 2. And then next week it will be everything you need for task 3. And then there's a week where I don't cover new material, we just do examples. And then the following week, everything you need for task 1 of project 2, and so on throughout the semester. So you have everything you need for task 1. Friday, I'll give you everything you need for task 2. Guess I'm just repeating myself at that point. So there's no need to wait. You're ready for task 1. You should be getting that done. The expected deadline was this morning. I did change the deadline. It was previously this morning. I changed it to Saturday. I didn't mean to scare any of you. But it should have been this morning. I extended it just because there are a lot of IntelliJ issues in the first couple of weeks. But this is where I would expect you to have task 1 already done, and you should be looking forward and starting to think about task 2 at this point. That's where I would expect you to be if you're keeping up to speed on all the material. So just to let you know where my expectations are. I did extend that deadline, but you should still be able to code task 1. And if you're having IntelliJ issues, you just might not be able to physically get the code where it needs to be and then submit it to AutoLab. And that's fine. We still have this week's labs to get it sorted out. The office hour schedule is starting to get shaped up. I have office hours tomorrow on Zoom. The TAs have a variety of office hours, and I'm getting on them to make sure that they get the rest of their hours on the schedule. We should have tons of office hours by the time all the TAs get their office hours in there. So with that, any questions, logistical questions or otherwise before we get started? Do this. Scala data structures. I want to talk about these 3 data structures. Arrays, lists, and maps. So arrays and lists are both going to be our sequential data structures of the course. I'll be upfront with you, we're not going to use arrays that much. I'm going to prefer lists in most of the homework assignments, but we will still look at the syntax for arrays. We already saw it a little bit when we were splitting strings, so you know some of the syntax for arrays, but we'll just get it all on one slide so we can see it and know how to use our arrays in Scala. And then maps, that's going to be our key value store. Lists is going to be the sequential data structure that we're going to use most often. So arrays, I'm going to give a very brief overview of how arrays and lists actually work. I don't want to go in too much depth. I'm not going to steal too much thunder away from CSE 250, which is going to explain ad nauseum how all these data structures work until you're sick of hearing about it. I'm just going to keep it very brief for now. I'll go in a little bit more in depth on lists especially, but arrays also when we get to learning objective 3 when we're talking about data structures. But I want you to have at least a brief idea of how these things work. So an array is a sequential data structure, just like a list. What that means is that order matters. You have values in a very specific order when you store anything in a list or an array. An array, underneath the hood, in memory, starting next week, we're going to talk a lot about memory. An array in memory is one block of code, one continuous block, one continuous block of memory. And your memory, this is going to be your RAM sticks in your machines. Memory is effectively one giant array where the memory is addressed at what we call memory addresses. Your values will be stored somewhere on that RAM stick. What an array is a continuous block, a physical section of that RAM stick where all of your values in your array are physically right next to each other in RAM. Maybe not actually physically, but according to the indices of the RAM, they're going to be next to each other. They're going to be sequential. What this means is that we can have something called random access, which effectively means it's really easy to access any arbitrary element of that array. Any random element that you want to access, very easy to access that. When you store an array, what you're actually storing is the memory address of the first element of that array, so you know where that is in RAM, in memory. I'll use RAM and memory interchangeably, by the way. We have the index, the memory address of the first value in that array, the value at index 0. And then if we want to access any arbitrary element of that array, we take the value of that first address, the element of index 0, and then add the index we're looking for multiplied by the size of an element. For example, if we have an array of doubles, the element size would be 64 bits or 8 bytes. We would multiply 8 by the index we're looking for, add that to the start of the array, and that's going to give us the memory address of the value we're looking for, and we can jump right to that memory address and grab the value we're looking for. It's very fast, very efficient to grab any arbitrary value by index from an array because it's a continuous block of memory. It's actually a little more in depth than I meant to go into, but that's fine. One thing that this implies is that an array cannot change size. You have one continuous block of memory, and if you wanted to add another element to the end of that array, well, you don't have access, you don't necessarily have permission to access that memory. It might have another variable stored there. It might be used by another program. It might be inaccessible. It might be the end of the memory even. We don't have any guarantee that we can access a specific memory address because we just don't have permission. It's up to the operating system to decide if we have access to that or not. And if it says no, we can't increase our size. So we say you just can't do it because you can't guarantee that you can always do it. So arrays are always fixed size. Certain languages will have data structures that they call arrays that can change size. So you might notice that and want to call my bluff. Those data structures, those languages have mechanics built in underneath the hood that will actually create new arrays when you want to add to an array. If you want to add to a JavaScript array and change its size, or an array list in Java, or a vector in C++, if you want to add to those things and increase their size, what's actually happening under the hood is when you create the array, the actual array, the fixed size array that's being created, the language creates one that's bigger than what you asked for. And then it has space to be able to simulate increasing the size. And once you run out of space in that underlying array, what it'll do is create a new array that's usually twice as big as the old one, copy all your values over to the new array, and then add your values to that one so you can keep expanding. So you get the illusion of an array that's changing size. But arrays fundamentally do not change size because it's just the nature of how they work. So the good stuff, the syntax of how to use an array. Today we mostly want to focus on how to use these things in Scala, just syntax. And this is it. We've seen a lot of this already. A new one is creating an array. And one thing I haven't mentioned yet that I wanted to save for today is when we create an array, the type of that, when we create a data structure, the type of that data structure must include the type that's going to be stored in that data structure. So when we split strings, you notice I was creating variables of type array, and then these brackets, and then string. We read that as creating an array of strings, or on the slide now, array of ints. This means that this array that I'm storing in the variable ARR array can only ever store ints. And that's it. If I try to put a double in this array, if I try to put a string in this array, if I try to put a Boolean in this array, I'm going to get errors. It's not allowed. This is an array of strings. It can only, ints. This is an array of ints. It can only ever store ints. It's going to be true for all our data structures in Scala. We have to specify the types. And when we say this, I read this as array of int. So if you have a task on the homework that says, write a method that takes an array of ints, this is what I mean. And we call this a type parameter. This array takes a type parameter, and in this case, the type parameter is going to be the type int. And when I actually create the array, I'm going to create an array and give it the values 2, 3, 4. Now, as soon as I create this array, from the moment I create this array, it can only ever store 3 values. Arrays are fixed size. So when I create this array, I have to know how big it needs to be. I'm specifying that by just giving it 3 values, initializing it with 3 values. And then this array always will be exactly size 3. This array stores 3 ints, period. That's it. And this gives us a continuous block of memory with enough room to store 3 32-bit ints. And that's the amount of space it has to work with, period. It can't grow. It can't get a 4th element. It can't go down to 2 elements. It will be of size 3 forever. So is an array just a list, but for ints? No. So I could have an array of strings. I could have an array of doubles, array of booleans. I could have an array of ints for what it's worth. Array is going to be our fixed size sequential data structure. And I think I just mentioned this in this lecture, but if not, arrays, we're not going to use too much this semester. Most of the homework assignments, by the way, this came up, I believe it was an email or something. Somebody was confused. I use homework and project interchangeably. So if you hear me say either homework or project, I'm referring to like project 1 pale blue dot. I'll sometimes call that the homework. So don't get scared if I say homework and you think there's homeworks and projects. They are the same thing in this course. I know that's confusing. I'll try to be good about that and call them projects. But I did get in the habit of calling them homeworks. So on the projects, I'll usually say write a method that takes a list, write a method that returns a list. We'll usually be working with lists. But I do want to show you arrays because we use arrays for splitting strings. Split returns an array, so we're kind of stuck. We have to use arrays at some point. Unless you convert your arrays to lists, which is something you can do. Right, you can change the value stored in an array though. The syntax is similar to most languages. We've seen accessing values, but this is how we would change them. Instead of the square brackets, we have parentheses. That's the only real difference. But this will replace the value at index 1, which is currently 3. It's going to replace that value with 20. So now the array stores 2, 20, and 4. So we can change the values, but we can't change the size. List is going to be the opposite. We can change the size, but not the values. For a little foreshadow. Accessing a value, we've seen this plenty of times. Just use your parentheses. And the index that you want to access, the value at which index, the index of the value that you want to access. Iterating over an array. I believe we've seen this, but if not, it's our standard for loop syntax for variable name in array. Do something with those elements. And something we definitely haven't seen is iterating over the indices of an array. This first example is combining things that we've seen. We've seen have we seen array.length? Maybe not. But we're combining things that we've seen. We've seen string.length, right? It's the same thing, I guess. But anyway, we're combining things that we've seen plus accessing the length of the array. For index in 0 to the length of the array minus 1 is going to iterate over the indices of this array. Or if you don't want the minus 1, 2, you can use until, which is going to exclude the endpoint, and you can do until array.length. Or what I prefer, I don't like having to remember which one is to and which one is until. I always get those mixed up, like which one includes the endpoint, which one doesn't. Should I have my minus 1 there? Should I not? I don't know. Just use array.indices. Indices is going to give you a data structure containing all of the indices as integers of that array. And then you don't have to think of any of this stuff. Plus, this just looks like a mess, too. It's error prone. You forget your minus 1. You get indexed out of bounds. You do until with a minus 1. You're missing the last element. There's just a lot to remember. Array.indices is going to iterate over all the indices of that array. Just directly let the array figure out which to use to or until or whatever. So I prefer using this one for sure. Both of these loops will just print out the indices. So both of these are going to print out 0, 1, 2. If you want to access the actual values, use the accessor notation, access the values, and then do whatever you want to do with the values of that array. But this is useful if you have a question like you saw in 115. Give me the index of the maximum value, for example. You would want to iterate over the indices instead of just getting the values directly. Yes, until excludes the endpoint and to includes the endpoint. All right, any questions on arrays? Any other questions on arrays? Yeah. Why can't we access what? We can access. I'm saying if we have like until and not our minus 1, like we might write this in a way where we don't end up reading the last element of an array. If we do indices, this will certainly access the last element, or the last index rather. I'm saying if we're coding this way and we just mess up a little. If we accidentally write code that doesn't. So if we had 0 until array.length minus 1, we would iterate over all but the last index of the array, and we'd be missing that last element. I'm saying if we use .indices, we don't have that risk. We just let the language take care of it for us. All right, lists we'll use a lot more, so let's talk about these. These are also sequential, meaning the order matters in a list. As opposed to map, I keep saying that like it's like of course they do. But if you recall from 115, I'll remind you when we get to maps. Maps don't have any order to them. There's no meaningful order to a map, to the keys and values. But lists are sequential, the order matters. The difference is they're spread all across memory. So in a list, you don't have one continuous block with all of your data. A list can be scattered all throughout memory. So in the way this works, which again, learning Objective 3, I have a whole week where I talk about lists and how they work and all that. So I'll keep it brief here. But in general, how it works is each element knows its value and where to find the next element in memory. So we have 2 pieces of information for each value in the list, for each element in the list, and we have a reference to just the first element. We can access that first element, ask it for its value, or ask it where to find the second element. We can ask the second element where to find the third where to find the fourth, etc., until we get to the end of the list. So this gives us a few features. One, it's easy to change the size of a list. You get memory from anywhere. You say, anywhere on this RAM stick, I need space to put my new element in my linked list. And then you tell the list, hey, you can find the new element over here. You tell the last element of the old linked list, hey, you can find it here, to append an element to the list. So we don't have the issue where we run into other chunks of memory that we don't have access to, because we can use literally any memory anywhere. We just get memory, and then tell our list where to find that new element. So we can have variable size, but we don't have variable values. We can't say the value at index 2 in a list, change that to 12. We can't do that. With list, I will say index. There's not really indices the way there are with arrays, but I'll usually say index just because it's more convenient to say instead of saying the value at position 2 or the value after moving two references down the list. It just gets cumbersome, so I'll usually just say indices as a shorthand. So lists, the first line, pretty similar to arrays. I'm going to create a list of ints, create a variable named list of that type, and create a new list using just list of the initial values that I want. So list containing the values 2, 3, 4, just like our array with the values 2, 3, 4, same idea. We want to access the very first element of a list. List.head is kind of shorthand for that. Or you can use the next two lines that we'll talk about, apply and just the parentheses. With the value 0, we'll do the same thing as list.head. The only difference is IntelliJ would be like, you could use list.head instead of accessing the 0th element, and then it'll want you to change it. To access a value at a specific index or position, there are two ways to do this, .apply, or if you want the same syntax as arrays, just parentheses and the index number for the value you want to access. So this is going to give us the value at index 1, which is going to be the 3. This is, for what it's worth, this is a much slower method. If you want like the value, if you say .apply of 500, you do have to do 500 hops around memory. So it is a much, much slower method than arrays random access. But these are the two ways. These do the same exact thing. In fact, just using parentheses like this is just a shorthand. What this does is call .apply. So you can say .apply or just access it using your array notation. Yeah. Ooh, I want to say no, but I'm not 100% on that. I haven't tried it in Scala. I believe Python's pretty unique in that feature. I want to say no, but I've never tested it in Scala, so it'd be something to try. I feel like it wouldn't, or else I'd know about that and be excited about it, because I like the negative one. I like that syntax Python gives us. And then the next two, append and prepend. So this is when we want to add values to our list. This is something we can't do with arrays, we can do with lists, which is why I prefer lists for the homework. Usually we want that versatility of being able to grow and shrink our lists. Mostly grow. Actually, I don't even have shrinking on here. But to grow our lists, appending, and the syntax is a little strange here. I don't know why Scala has such different syntax. I'm sure there's a great reason, but I don't know what it is. But colon plus. So the list that you want to append to, colon plus, and then the value, the new value that you want to append to the end of the list. If you want to prepend, the value, and the order matters here, list then value, value then list. It visually shows like where you're putting the value. You have to follow that. The value, colon, colon, then the list. So this prepends to the beginning of the list, this appends to the end of the list. And the order, list, and element have to be visually where you would actually expect the values to go. What's really important about these two lines is this part right here, list equals. So when you make a change to a list, the list, I already worded that weird. The list itself isn't changing. So this list that contains the values 2, 3, 4 never changes. Ever. Doesn't change. When we say list append 50, what we're actually doing is creating a brand new list with the value 50 appended to the end of it. So this expression that's highlighted will evaluate to a brand new list containing the values 2, 3, 4, and 50. But it will not modify the list. Will not modify it at all. So if we want to see the change that we've just made, if we want to see that value 50 and have that affect our code that we're writing, we have to reassign it to something. We have to assign it to some variable. In this case, we're reassigning to our original variable, list. So list is a var, so it can change. I'm going to reassign it to this new list that we created with the value 50 appended. If we don't have this list equals, we can't see that change. It'll be like nothing ever happened. Same thing with prepending. List equals 70 prepend list. Now we have a list. The variable list here is going to have the value 70, 2, 3, 4, 50. If we don't reassign, if we just have this without list equals, we're only going to have a list with 2, 3, 4, and 50. We're not going to have that value 70 in our list. And then no matter how much I say this in lecture, I always have somebody in office hours, which is fine. Sometimes you just forget or whatever. Somebody in office hours will have just this part without list equals, and they'll say, and it's a really frustrating thing. I've done this before too, to be honest. It's really frustrating because you're like, my list, I'm printing it to the screen or I'm using it in my tests, and it just doesn't have the value that I added. But it's right there. I added it there. I added the value. I prepended it, and it's just not there. The computer's not listening to me. It's supposed to do what I say, and it's not. It's because you're creating the list. You are prepending 70 and creating a list with that prepended, but if you don't reassign it to your variable, you can't see the change. And you've seen this in 115. You've seen this already with strings or even with just integers. If you say concatenate two strings, you want to concatenate something to the end of a string that you have to reassign that to your variable, or else you can't see the change. It doesn't happen. Same thing with variables. If I say x equals 7, and then I want to add 1 to 7. I just want to, or add 1 to x. I just want to increment x. I can't just do x plus 1. That's going to evaluate to the value 8, but if I'm not doing anything with that value 8, it doesn't help me. I have to do x equals x plus 1, or x plus equals 1, or in some languages, x plus plus. I have to do something that reassigns that variable, reassigns the new value to that old variable, or else I can't see the change. Same thing with lists. I'm creating a brand new value, which happens to be a new list. It's more complex than a new string or a new int, but it's still just a value. I have to reassign that to my variable, or else I can't see the change. What happened? This is actually asked in the other lecture too. What happens to the original list after reassignment? I'll try to keep this brief. I'll give a similar answer to what I said in the other lecture. What happens to this original list after these operations? And it's actually a pretty complicated answer that, again, we'll talk about in Learning Objective 3 when we get there. But when we append to the list, we create a brand new list with 2, 3, 4, and 50. That's assigned to list. And then this list is candidate for garbage collection. Like Nicholas says, reduced to atoms. It's going to be gone. Gets destroyed. Garbage collected because we don't need it anymore. When we're prepending is a little bit different. 70 is actually going to have a reference. It's going to have the value 70 and know where the beginning of this old list is. It's going to know where this 2 lives. 2 knows where 3 lives. 3 knows where 4 lives. So when we're prepending, this list is actually remaining in memory and being used as part of this new list. So this new list kind of absorbed the old list and reuses that same memory, so that would not get garbage collected. There is a big difference between prepend and append. Append is a very slow, bad operation because it has to copy this list because we're updating 4. 4 now knows about 50, but this list can't change, so we can't reuse this list. So that's my kind of short explanation. But append is slow and prepend is fast, if you want the TLDR of it. And it has to do with garbage collection. That one just, I don't have the focus to read that line even. I just see the array and string and lists all over the place. But yeah, you can nest them. I think that's what's being talked about. So you can have a list of arrays of ints, for example. You can nest them as much as you want. All right, let's get on to maps. Maps are going to be our key value stores. These are our dictionaries in Python, our objects in, eventually I'll learn to not step on this. Our dictionaries in Python and our objects in JavaScript I think they're still called just maps in Java. Depending on, I think you have to specify the type of map you want, so tree map, hash map. And I believe maps in C++ too. I shouldn't even say anything if I'm not sure. But these are typical key value stores. Instead of storing values at indices or at positions, we're going to store values at keys of our choice. The default implementation is hash map for what it's worth. I'll leave the details of that for 250. Somebody did ask in the other lecture, so I went and do it just a little bit, but I don't really want to. I mean, I do want to actually, but I assume many of you won't care. Is that a safe assumption? Anyway, but these are based on hash maps. So a hash map, I will do it anyway. Screw it. A hash map is an array, and the values, the indices of that array, are going to be the hash values of the keys. So when you have a key value store, you have a hash function. You're going to hash the key, and then that value is going to be stored at the value of the hash of the key in the underlying array. Is my very brief explanation of what a hash map is. But that's a 250 topic. 250 is going to tell you all about hash maps in much, much, much more detail. How to choose the size of the array, for example, is a very big question with hash maps. But it does give us a lot of efficiency. Maps have variable size and variable values, so we have a lot of flexibility in how we use our maps in Scala. And as always, we cannot have duplicate keys. You saw this in any language, any key value store. You can't have the same key multiple times in your map, in your key value store, mapping to different values. It just doesn't make sense. It doesn't work. If you add, I think in any implementation, but certainly in Scala, if you add a key value pair with a key that already exists in the map, it will overwrite, the value that you're adding will overwrite the old value that was in the map. So whatever the latest value that you added at that key, that's going to be the value stored at that key. I realize how much I don't know. None of us know anything is the big secret. Been doing this for 2 decades now. And there's still so much stuff I don't know. There's just so much to know with computer science, and it's evolving so fast. It's practically impossible to keep up. Yeah? Yep. Yeah, you can have a map of ints to map of strings to arrays of lists of, you can nest them however much you want. Yep. We'll avoid that for the most part this semester, but it is something you can do. To comment on what I was just saying, I want to cap that with something more positive, and that's okay to not know anything. Like in this field, like you're not expected to know everything. Like ever. When you graduate, you go to the first, I see a lot of seniors or sophomores and juniors going for that first internship interview, or seniors going for their first job interview. And they're nervous, like you get this job posting with all these technologies that you've never heard of before, and you're worried that you're completely underqualified and all this stuff. Don't worry about it, just chill. Go to that job interview. And when you get there, they're not going to expect you to know all those things. They might not expect you to know any of those things. In a lot of my job interviews, they'll be like, do you know about this technology, whatever. I went to one, it was triple stores, I think it was called. They're like, do you know about triple stores? We use those on a daily basis here. I'm like, I don't know what those are. I had my default answer. I'll try to get in interview mode. I'd say, I haven't worked with those personally, but I'm confident with a fairly brief time frame, I would be able to study them and be able to use them on a daily basis. That was my go-to answer for an interview. It's okay to not know a lot of things because the expectations are unreasonable. The people who do know everything don't exist. So how are they going to get the job over you? They're not out there. They don't exist. So you kind of have to find your niche. Find some subfield specialize in that is typically the strategy. All right, enough with that tangent. You should apply to internships as soon as possible, like next summer. You should be applying for internships this semester for next summer. Don't wait till you're a junior to apply or a sophomore to apply. Yeah. Java has array lists. Array lists. There might be an equivalent in Scala, but that I'm not familiar with. It doesn't map to any of the three we're talking about. Array list is a wrapper class for an array. So underneath the hood, it's an array, but it does that resizing thing that I was talking about earlier in the lecture. It'll do the automatic resizing. Once you run out of space in the array, it'll create a new one of double size, and then copy all your values to that. That's what the array list is doing. I feel like there would be in Scala. I don't know of it off the top of my head, though. When I need an array list, I'll use a list in Scala and accomplish the same task, but you have to use them a little bit differently. All right, so map syntax. Oh, goodness, you're talking about AVL trees and red-black trees? No, that's definitely 250 material. I don't even mention in those. Actually, I do mention those in Learning Objective 3, very, very briefly. So maps, a little bit new syntax here. One, you can have different types for the keys and the values in a map. I'm using the same type here. I'm using ints for both. But when you create a map and create variables of type maps or have methods that take maps as parameters or return maps, you have to specify two types, the type for the keys and the types for the values. And they can be different. You could have a map of strings to ints. Here I have a map of int to int. But you can have any types. You can have, like we were saying earlier, a map of strings to a map of, whatever. You can nest these things. But you do have to specify both types. And then I'm creating my map of a key value pairs separated by commas. Same thing as lists and arrays where we have comma-separated values, but now our values are key value pairs, and we're seeing our second instance of Scala's love for arrows. Holy crap, it's 2:39 already? It's fine, we're going to definitely get through all the material. But we're going to see our second case of Scala's love for arrows. We're going to read this as a key, 2 mapping to some value, so 2 maps to 4, 3 maps to 9, and 4 maps to 16. So this is how we create a key value pair, is with this little arrow pointing to the right, which is a dash greater than. When I add a key value pair, I'm going to use the plus sign. Again, I don't know why Scala has so much different syntax. Once you start using it, I do actually like it, but it is a lot when you're first learning it. It's the plus sign to add a key value pair to a map, and add a new key value pair with the same syntax as when you initially created the map. Again, make sure you reassign. This is creating a brand new map, so make sure you reassign it to your variable if you want to see that change, or create a new variable for the new map. But you do need to do something with that new map you created, or else you won't see the change. To access the value at a particular key, you can use the same syntax that we did for lists and arrays with the indices, except you're going to give it a key. I'm going to give it the key 3. My keys happen to be ints, so it kind of looks like an array access. But I would give this a type of whatever my keys are. If I have a map of string to int, I would say my map of some string, and give me the value at that key. So this gives me the value at the key 3, which is going to return 9 in this case. But using this syntax, if that key is not in your map, it doesn't just give you a soft warning. It doesn't say, hey, that's not cool, that's not in the map. No, your program crashes. Just done. So this is a bit dangerous. Unless you know that key is in your map, don't use this syntax. You have to know that key is in your map. Which is, often the case. Sometimes you'll say, if this map contains this key, then do this, else, you can do things like that to check and be 100% sure. But if not, get or else is our friend. Get or else is going to get the value at that key that we specify, At this one, give me the value at the key 100, which of course is not in this map. Else, if that key is not in the map, return whatever I give as a second argument, in this case, -1. So in this case, 100 is not in my map, so this is going to return -1, and y is going to have the value -1. And finally, iteration. So we do have dot keys and dot values, like you've seen last semester, if you took 115 here. We do have dot keys and dot values. Did you? Oh, never mind. But for my money, Scala gives us this syntax, and I'm going to use it because it's really convenient. I really like this syntax. We can put in parentheses 2 variable names. I'm just naming them key and value because it's the first example of this. But you can name these whatever you want, maybe city and population, or whatever you're storing in your map, something that identifies what that information is. For key and value in my map, and iterate over the keys and values simultaneously. Even if you don't need both keys and values, I still like this syntax because it's nice, convenient, compact, it's clean. Even if you don't need both of them, why not iterate over both of them? And saying, instead of saying, like, if you just need the values for value in my map.values, like it's as much typing as this. And then if you change your mind and decide you want the keys, you got them there, right there. So I like this syntax. And also, instead of iterating over the keys, and then if you want the keys and values, you have to do my map.get or parentheses of key and store that in a variable to get the value. Nah, just do key and value. So I like this syntax. If you only use that syntax to iterate over your maps, I ain't going to be mad at all. I'd be happy, in fact. And then you have both those values, key and value, iterating over them simultaneously with nice compact syntax. But if you want to do it the old way and you want to do for key in my map.keys or value in my map.values, you're welcome to do that as well. It's perfectly fine. Yeah, and for get or else, if this were get or else 3 -1, this is going to return 9, and y will have the value 9, because that key is in the map. Just to round out that example. So the rest is reinforcing this in IntelliJ. Surprised it took so long to go through 8 slides. There's one thing I want to pick out here. This, I have a list. I'm creating a list, and then I'm just mucking around with the list. If I do this, the value 13 never gets appended to my list because I'm not reassigning it to the list. So this change doesn't really do anything. I have to do primes equals and then append, prepend, whatever I'm doing with my list. I have to do primes equals or else primes isn't going to contain that list. When I print primes here and I print primes here, it's the same exact list. 13 isn't in that list because I didn't reassign to the variable. So I created a new list with 13 appended, and then I just left it on the floor and walked away from it. Didn't do anything with it because I didn't store it in a variable. I didn't do anything with that new list I created. Even IntelliJ's yelling at me. It's like, you didn't do anything. You have a line of code that does literally nothing. Like, why did you do that? It has no effect. There are shortcut operators for those of you who are comfortable with the syntax and want to use them. Colon plus equals will do the reassignment and the appending, all in one compact syntax. Colon plus will prepend and reassign. And same with maps. Oh, come on. We do have plus equals with maps if you want to add a key value pair and reassign in compact syntax. Just like plus equals for integers, we had that same thing. And I think that's the useful ones that I want to point out. Let's go over here. And as always, when you finish the lecture question, you're free to go.